Hello everyone, in this video I want to show you how to clear up your Docker setup, and in the end of the video I want to show how to clean up var libdocker directory, which can pile up to huge sizes. I have already pre-pulled some images and started some containers, so there is stuff to work with. So here are the images. Here are the containers. There are two running containers, these two bottom ones. One is Nginx and Postgres, which has an anonymous volume. And this is one built from my custom Docker file. It's a simple one, but I have started it with named volume so that we can see two types of volumes. The Postgres was started with this command, so there is no mentioning of volume here, but Postgres container has volume declared in its Docker file. And if we list the volumes here, this is one for Postgres, so it's not named. And this second one is named. It was declared specifically when I ran my test container and I specified the test vol as volume for some directory in my container. Now let's see which tools Docker does provide for clearing up space. We can use docker systemdf command to see how much space is used. There is verbose version of this command where you can see how much does each image, each container volume occupies. The first step that we can do to clear up space is to remove unused containers, stopped containers. You need to make sure that you don't need them already. When you do docker ps, you see only running containers, but if you include -a flag, you see the stopped container. Here's exited status. And if we, you can also see the containers with docker container ls. And this command has prune subcommand. If you invoke it, Docker asks you if you want to delete stopped containers, and you can press yes, or you can include -f flag to force it to prune those containers. And here it is removed. And as you can see, we don't have that container now. Now let's clear the images. Here are all the images that I have. And the test image is the image which was built from this Docker file. Let's now modify this Docker file. For example, I'll add something simple like this, just another extra step, and build the image without specifying the tag. So I was specifying tag like this, but now I will just run it like this. And it was built. And now if I list the images, you see this entry where the tag is none and repository is none. So this is the image which is called dangling image because it doesn't have the tag. And when you prune the images, when you run docker image prune, it asks you if you want to remove all dangling images. So now if I press yes, that image will be removed and all the other are left. Now we want to go, we can go further. Let me show this docker image prune help. There is all flag, which removes not only dangling images, but all unused images. Let's try this. If we run this, there are some more images being removed, and only these two are left because all other ones were not used by any running or I guess stopped container as well. So if we list the containers, we see Nginx and Postgres containers, and the relevant images related for them are still present. Let's see which containers we are left with, and volumes as well. Test volume is still present, although we have deleted the container related to it. This is the feature of named volumes. When you delete the associated container, the volume is still present. And Postgres volume, which is unnamed, is still present as well. But if I remove the associated container, so let me copy its ID, it cannot be removed because it's still running, but I can force the removal. Container is removed, there is no container left, and volume is still present. Actually, that's my mistake, because both unnamed volumes and named ones are present after associated containers are deleted. But there is docker volume prune command, and it treats these volumes differently. So let's see the help page. As you can see, just docker volume prune should delete only anonymous or unnamed volumes, but when you include -a flag, it will remove all unused volumes. So that means that volumes which don't have containers that use those volumes will be removed. But those ones that are still used by some containers will be present. So let's prune the volumes. The anonymous one is gone, and this test volume doesn't have associated container, but it's still present. But we can remove it by including the -a flag, and there are no volumes left. There is also a docker network prune command, but I'm not gonna use it here. I will show you the docker system prune command. This one is supposed to clear all things in Docker. By default, it wants to remove all stopped containers, like docker container prune command, unused networks, like docker network prune, dangling images, like docker image prune, and it prunes unused build cache. So let's do this. It cleared up another 55 megs. Let's now run docker system df. So 500 megs is still used by images, and some space is used by containers. Let's now include prune -a flag. The difference to the previous command is that it removes also images which are unused by containers, not only dangling images. It's like docker image prune -a. And now it removed also Postgres image because I have deleted Postgres container previously. And the only image which is left is Nginx because I have Nginx container running. Now let's remove this container because no docker prune commands will remove your running containers, even with force flags. So let's remove that one and run docker system prune -a again. And now we don't have images, we don't have containers, and we don't have any volumes because we removed them before. But docker system prune command also has a flag for removing volumes, but this flag removes only anonymous volumes. So if you want to remove all unused volumes, you need to use docker volume prune command with -a flag, because docker system prune won't remove those volumes. You should be careful when running these commands. Think through your steps really well so that you don't lose any data. When you're removing containers, think about which files might have been created in those containers after they have been started. When you remove images, think about whether there are some images that are not pushed to some remotes and just built locally, and whether you have Docker files to reproduce your custom images. And especially be careful about volumes, because oftentimes they contain database data or some other important data. And now it seems like I have removed everything and there is no space occupied by Docker anymore. Let's verify by running du command on var lib docker. This is the directory where Docker stores its files, and there is really small space occupied here. But in my experience and in experience of some other people, var lib docker might grow substantially without any visible reason for that over time when you use it. For example, here's the screenshot from one of my work VMs, and here Docker consumed over 100 gigabytes, although I have cleaned every container and every volume, but still the var lib docker overlay to directory was huge, and it's not a singular example. Here is the big thread on Docker forum about this issue, and one person shared that his 80 terabyte drive was almost full after using Docker for several years, and overlay to directory grew massive, and he solved it by following these steps. But I want to show even simpler way to clean. This way would work only if you don't need anything from Docker. So either you have backed up everything you need, or you don't need anything. You don't need containers, volumes, networks, images, nothing. So it will just wipe everything from that directory and start Docker from a clean slate. It's like reinstalling in effect, but without reinstall. Here is the popular reply on Stack Overflow from prominent person who wrote a lot on this platform. What he does is stops Docker, removes this directory entirely, and starts Docker again. So let's do it. I will stop the Docker service. So Docker service stopped, and let's remove var lib docker and start Docker again. Let's do Docker ps, and let's build this Docker file and do something else like Docker run alpine image. It pulls the image and starts the container. So everything works fine now. And that's it. Thank you for watching. If you found this video interesting and useful, please consider liking it and subscribing to my channel. The war in Ukraine continues, so please consider donating to Ukrainian defenders to help fend off the aggression. You can do this by donating to Come Back Alive Foundation, link in the description, or by any other valid method that you find.